everybody, welcome back to another round of I make something or do something with my server.
Alright, so as it turns out, there's a bit of missing footage, or at least footage that I didn't even bother to record, and that is some context. Some very necessary context about what's going on in today's video. Because, I mean, you look at it, you watch part 1 and you'll realize that, well, there really doesn't need to be a part 2. I mean, we've installed RAM, we've got a new SSD, we've even installed hard drives, and you'd probably be asking the question of, are you really just milking this for the subscribers because you did so well in the first one? Well, yes and no, but anyways, but there's some very important context, because if you really watched part 1, you might have seen that the front panel lights on this thing are a bit more different. That's kind of why I chose this thing to be a server in my case. Yeah, because the lights, there's a lot of unused front panel lights, and we're going to be putting them into use in today's video. So I'm going to drop you into it. So basically I built a little prototype with an Arduino, which is kind of hard to get in on camera and in focus, but yeah. So we just got an Arduino Uno and yeah, all the unused LEDs. Unfortunately, it's still not in focus or not in shot. But yeah, so we're going to be converting that into this board with the headers, with all the required headers for the 6 unused lights and 1 unused button. And while we're here, because one of the original ideas for it, in fact, I think what they were trying to go for with all those extra lights, was an alarm system. So I'm going to include a little buzzer, because with this now becoming a server, I'd like to have it where if it turns off, like if it gets shut down, like without really being safely shut down, maybe have it where it'll be an alarm to turn right back on. Yeah, because got to keep the services up somehow, and I don't know, sometimes power could be unstable. But anyways, I'll jump cut to right after I get all the stuff soldered. So yeah. Alright, so off camera, I built the circuit. And yeah, there it is. Unfortunately though, autofocus is not cooperating, but if I can just go into good old manual focus, you can see how, well, it's one of these circuits built with an Arduino. Not my best solder job, but kind of the first time I've actually, I think this is the first time I've actually soldered onto a PCB of some kind. So that turned out pretty good for how I do things. So yeah, so the next thing to do is get it all tested. And so the way I'm going to do that is I'm going to plug it into my gaming PC, because the server doesn't have the tools, or I'm not about to get the tools because I know the tools exist on Linux where you can just talk to this over serial, because the way this thing works is that it uses the serial port, and yeah, it just talks to, and it has like a little syntax, and I'm probably going to do a bit of a code overview that, probably the most skippable part of this video. So let's get this tested. Alright, so I'm going to kind of interject before I do get to the test and explain how the Arduino side of things works, because we're still working on the drivers, which I'm going to be writing in the C programming language, and that's because I've got actual knowledge in that, and you know what, it's easiest, and we don't need all that much. We just need something that will start when it boots and will be good. So yeah, the way this will work is that we have the Arduino, which is what's being shown in the video, and yeah, so we have the include statements here. This is red because the way I did this initially was I used the actual Arduino IDE, but here I'm using VS Code, so it's But what this does is it handles reset, because one of the features that I've added is that if you press and hold the reset button, it will actually reset the Arduino. And that's because even though it is a reset button and we could have just tied it to the reset pin like an actual Arduino thing, it just didn't sit right with me, and it would have involved like having to reinstate it, even though there's nothing really to do in that case. So what it is that it's got a system where you hold it down for like 5 seconds and that'll reset it, and avr/wdt.h, what that does is it adds the functionality to do that. In fact, right there is, and so here we have pin definitions, button state, and serial communications. All this code is actually going to be open source once I get this done. These are all default settings. This is where the pinout is. This is kind of something that I use quite often throughout today's video, kind of in thoughts, but not in, I don't really put it down in there. But this is kind of the blueprint. It's just a weird way that I work. And so serial timeout and alarm timing, they're pretty important ones. So we'll start off with setup. That just is a lamp test. It beeps the buzzer 2000 hertz for a second, stops everything, and goes back to normal. The only one that isn't controlled by the Arduino, in fact, the only light that we've added that isn't controlled by the Arduino is the power supply B light. Now, that light is rather powered by just the 3.3 volt lines. I had it set up like that because really it's on an always on USB, because the motherboard it's on, which we've kind of discussed in the previous videos, being one of the high-end ones, it actually has an always-on USB feature. I think that was a pretty common one on motherboards. I know my cheapy little laptop that I've been using for the past 11 years is like that as well. But anyways, so now we get to the important bit with the loop. So we start off with the button. This is just to make sure that in between the time of the button, of the code being run, the button hasn't changed. It gives enough a bit of a time to measure things, because it's very useful to get the edges of the timing for it. It's kind of a bit difficult to explain. I'll probably try and make some kind of motion graphic. I don't know. I gotta rush this video out. Anyways, so what we've got here is, then it goes into serial. Now, this is also very important, because what happens is that this is checking for if you have a serial connection. If it doesn't hear anything, if the Arduino doesn't hear anything from over serial for like 30 seconds, and when I mean serial, I just mean the USB port. If it doesn't hear anything within 30 seconds, what it'll do is that it'll start running this code, which I know it's nesting, but it's kind of a bit, I don't know, it's kind of the best way I found, it's kind of the best approach I found. And what this does is it just blinks if it's not doing that. I might make a future update where like every few cycles it might beep, because again, like I explained in the section before it, the point of this is to be an alarm. If services are down, we need to get them back up, because I actually rely on this server quite a bit in my college work, because as a college student, I like having a place to store my notes. I don't trust anything other than Nextcloud, so I'd like to have my server up all the time, and if it goes down for any reason, I'd like to have whoever is nearby know. Although really, skipping ahead a bit in time, it does make it is a bit more, I'll just say, a bit quiet, the alarm. So I don't know. I have to decide upon that one. You'll know it when you see it in the version that I released to GitHub, probably alongside this video. And it also has an override for if you safely shut down, where I think it just, actually no, it's inverse. So it would just go low. So, but if it did, it would be, but what happened is that if it was safely shut down, like we knew that we shut it down, it'll just go high and it will never turn on, because scrolling back up, there's the safe shutdown Boolean flag thing that I built there. And then moving on to below that, there is stuff to now receive the data. So there's character command. It is a one character string. I shouldn't have made it. In hindsight, it really shouldn't be a. What is it? It shouldn't be a list, or actually what it's actually called, an array. It shouldn't be an array, but it kind of is, because when you get to this line, serial.read bytes, it doesn't like anything other than arrays for some strange reason. So yeah, and if you go further on, you'll see that really it's a very simple piece of code. It's because it's reading bytes. It reads 1 byte. Every command that goes down the serial port is 1 byte long, excluding the CPU command, excluding this one. And so down here is the switch case. We've got all these different commands. So you got C, which turns on the hard drive 2 light. I have that there because this way we have something that will always have some kind of updates. This way we never fall behind our little 30-second limit that I've set, so it doesn't think that the computer has accidentally shut down or crashed or something weird happened in Linux or something. Yeah. But anyways, there's B, which is PC booted, which also is an optional one where it turns off the fail light, or at least turns off the safe shutdown. And because it's a serial command, this whole code will still not work because, well, hey, there's stuff going on. Everything is working. It's all getting its data. It's gotten data in the last 30 seconds, so this code does not apply. You got S, which means PC has been safely shut down. So that turns off and resets everything, turns on safe shutdown. And since this code knows to avoid safe shutdown, which I don't think I've actually tested really, and it'll just keep running the code. And then there's these other ones, which are if something catastrophically went wrong, and oh boy, I spotted a little bit of a typo there. But then there's these 3 commands, which are for the left side of the panel, and these are the ones that you really never want to see. So there's like case F, which is fan has gone out. So if it sends down F, then that means that the fan has gone to an RPM 1000. I think I've set it to be it's about a 1000 RPM below spec. So like whatever the motherboard says the RPM should be, this was 1000 RPM below that, and therefore the fan's probably dead or something stopped it, which is kind of hard because I actually tested it. It's kind of hard to stop that fan, really. And then there's T and Y. I just chose those ones because, next to each other on a keyboard. T is if the first temperature goes out, which by default in the driver software, which is this stuff, which is very unfinished, you'll see that there's 2 temperatures. This is the first one, 70 degrees Celsius. That's kind of the temperature that the Raspberry Pi was running at when I had the Nextcloud on that. I feel that if it gets up to that on this server, then something's up. Something's gone kind of wrong. Something's starting to go wrong. So it's kind of a nice little warning to have this first temperature go out. And then there's temperature Y, which goes off at 100 degrees Celsius. Now this is in Celsius, so so when I say 70, I mean like this is getting to 3D printer build plate temperatures. 70 degrees Celsius is quite a bit. And there's 100 degrees Celsius, which is, well, A, enough to boil water, and B, well, that's probably going to set your CPU to thermal throttle. If I remember right, that's what thermal throttle temperature is. I'll have to read up on the data sheets for these things. And then there's this last one, which is a force reset. If it sends a force reset, then that means, well, no... so that means just turn off everything. Basically does like what this does, but it's in the expectation that there's going to be more data to be thrown down the line. And finally, we get to the if somebody sends a null character, case /0, which is null character, then there's a break. And if none of that happens, which is the default case, then print out an E for errors. Now, unfortunately, though, there is a bit of a bug in this code where for some reason it thinks of some things as errors, like the lack of data as errors. I'm not sure what's up with that, but oh well. Anyways, it doesn't hinder the how it works, but I'll just probably have it as like a, I don't know, I guess it works. There we go. And then finally we get to the button handling, which is what makes use of this, all of this stuff to start time gap, and then and then you've got this, which will reset the alarms. This is your initial press. So like if you just press it once, it'll just reset the alarms. So that just does what the R command does. I really should have put this in its own function, but I kind of chose not to. I'm not sure why. I'll have to get with the past version of me, the version of me that built this about a week or two ago, and really have a nice word with him. Anyways, and then there's the reset, which just So if it detects that it's been pressed for 5 seconds, then it just does disable, enable. Now I got this code from the Arduino forum, and there is something that I'm not too certain about and why it's here or why it's needed. It's almost like that one case of, what's it called? The valve. It was like the valve coconut or valve banana thing, where a TF2 dev had a banana or some image of a fruit of some kind that appeared in the TF2 source code, and they removed it, and then the anti-cheat started being like, it doesn't work. This is kind of one of those cases. It's just a while loop there. It doesn't really mean much. It doesn't hinder anything because really, this is a reset. I guess it just checks out because, force the CPU to stop doing things and, stop working as the rest of the CPU takes hold and starts doing stuff. So, that's literally all of the code for the Arduino. And then we've got to deal with this, but that will be for later on in the video, and maybe even off camera and off the video. Alright, so here we are back in the server. Have this big wire bulging out here with the sticky note attached to it because, when this was built, they had these LEDs here, but they didn't really. But of course, since they didn't make use of them, there was one where I think it was the power supply fail light was not really attached. So what they did is they just kind of had a green LED that they just took out of the box and they just stuck it in there. Now I replaced it with a red LED and soldered one of these wires to it, which is actually from the thermocouples for the 3D printer, but since my 3D printer doesn't really use this type of connector, but this fits so well as a pin header connector, I just figured I'd just use these because I've got so many spares from when my printer was just in and out of repair. Anyways, so what we're going to do is we are going to have to unclip this zip tie, but with the wires that I used to put this together, it came with some zip ties of similar design in box, so hopefully I'll be able to redo it. I would go and try and do it in a reusable fashion, but it's just, I don't feel like doing it. It's not in the cards right now, so let me just grab the wire snips and clip. Unfortunately, that's kind of how it has to be, so So now what we're going to do is, now that we're there, we're just going to hook everything up. Let's fire it up and see which pins work when I send serial commands to them. Alright, so this first attempt, I'm going to kind of just sum it up here. It was mostly a failure, but there were a few things that were notable. On the power-up test, which I think is going to happen in a moment, which it just passed, all the lights should have come on. That didn't happen, so that means that some of the connections are backwards. Not a problem, that's just a matter of flipping around the connectors. and that's what I mostly did. Unfortunately, though, there was another problem. The buzzer didn't come on. I don't have the audio on in this clip, but if I did, you wouldn't hear anything because the buzzer's supposed to be on. It's supposed to beep during that test. So, back to the drawing board for that one. Alright, so we're a day later, and yeah, we've got this board all remanufactured. Now, from the testing, we were able to get it to mostly work. This buzzer didn't work, or this buzzer that was not in frame, but now is. It didn't really work all that well. That was mostly because I wired it backwards, and the plan was really, the way I had it wired on the breadboard worked, and I replicated it basically the way I tried that I thought the breadboard had. But yeah, I tested it again. You know, I just needed to test the buzzer, so yeah. And yeah, made a nice beeping sound, which is what I wanted. Yeah, another thing I was planning on doing was I was going to make a little wiring harness for these last two pins here, which are not in frame, but yeah, these last the two pins to the left, I was planning on using those to connect to the motherboard's PC buzzer header, so this way I could get post beeps, because we could do that with this. But I decided against it because the way I connected it, I wired it up, is not sure if I really like it, because the way I wired it is that it just kind of merges the two together. It just merges, it's just two wires, they merge together into the speaker. I'm not too sure if that's how I want it to go. I might build it just for fun. You know, I might just build it and plug it in. But I mean, if it's not running, we should be able to get visual on it. You know, this will have a monitor hooked up to it because although I'm kind of preparing for a comment that I'm expecting to get on this video, one of the big things that you might have noticed from when I actually showed this thing on screen, you may notice that I used a desktop operating system. Like I used Kubuntu because I have a KDE desktop on it. Yeah, and I bet you there's going to be some Linux purist in the comment who will be like, you should probably be running it without a desktop environment. And yeah, while that is a truth, I could probably do without. Well, I'd rather have the desktop environment there because although I can navigate in a terminal, sometimes I get a bit disoriented and it's like, yeah, there's a lot of reading that has to go on, and sometimes I like having the nice visual of the file manager just there for it. But also, when I do my Nextcloud work, it doesn't really take much overhead, really, because, yeah, and this will also address another comment that also came in. Apparently, the motherboard can handle 64 gigs of RAM, which is a bit funny, because the manual says 32, but then again, I researched the manuals for the lower-end models of this motherboard, and they screamed that it can do 16 gigs of RAM, which I think Asus is kind of lying there, because there's one commenter who said you could get 64 gigs of RAM out of it. Well, I don't really need 64 gigs, because as it turns out, when I loaded in Nextcloud, in fact, I'm probably going to have a nice screen recording of my Nextcloud instance's CPU resources on it. And yeah, it just takes not too much RAM. I think it takes mostly like 2 gigs at best, so yeah. Oh, and another thing I did that I noticed when I was doing the tests last time, in fact, I think I may have pointed this out, apparently the power supply B button, or the power supply B light, that wasn't connected to anything. There was no connector going to it. So, I made a connector for it. So yeah, it looks like Hughes, when they built this thing, what they did is they just, or at least whatever manufacturer off of AliExpress they got this case from, when they built it, they just put in some LEDs, because I guess they used some case that I guess this is some case that's pretty common or is available through either Amazon or AliExpress or something like that, and they just had, or at least the front panel headers are, and they were designed for actual servers where you would probably have two redundant, where you'd have the extra redundant power supply and then you'd have extra hard drive lights. This doesn't have it. The motherboard doesn't support a second hard drive light. and I believe the fault power supply system requires some kind of like lights on manager of some sort. I'm not too sure on the correct terminology of it, but yeah, it requires some kind of like manager or some kind of like daughter board to handle to see if there is a fault in the power supply. And it also needs something similar to what I am building here for these reset fan temp 1, temp 2 lights to work perfectly. So yeah, that's a very interesting. So it's very interesting how it was built, but yeah. But anyways, so we're just going to get this installed and clipped back in because this is the original LED as I found it. And yeah, so now you may be asking, well, so what are we doing with this fine device? And how are we going to plug it in? Where are we going to put it? And, well, you're asking all the right questions. Luckily, though, those questions just so happen to have answers to them. So first we'll start off how we're plugging it in and where we're plugging it in. Now this is probably going to be the one where I'm actually going to get flamed in the comments for. So because Arduino is powered by USB, we are going to use USB. Now this motherboard has attached to it into that PCI slot back there is a bunch of serial ports, but we're not using those because it's kind of, I don't want to deal with the nightmare of wiring those up. So yeah, so we're just using the USB port. And this is where it really gets horrible. I have this here, USB 3 to USB to front panel-ish USB extender thing. Yeah, so we're doing this, not because I want to, but more because I'd rather not mess with the stuff that's already there. And yeah, as it turns out, both of the USB ports on the motherboard have been taken. Both the USB 2 connectors or style connectors have all been taken. So in order to mess with it, I'm just going to use the USB 3 connector, the one USB 3 connector, and we'll keep it inside and we'll just have that there. I know it's horrible because, you know, really USB 3 does not deserve to be connected to just one thing that's running at basically USB 1.1 speeds just to connect over serial and send like 1 byte every, I don't know, 0.1 seconds to tell the user to flash some lights on the front. But I'm gonna say just desperate times call for desperate measures, really. And yeah, and so yeah, and then that'll just plug into the Arduino. And yeah, and then coming on to the next question of how we're going to mount it, well, that's also pretty simple. So what I've got back down here in this drive bay is we have a bunch of these 5-inch slots, and I figure that with a bit of 3D printing and a bit of magic, I could fit this whole design into a 5-inch slot. I mean, there it is right now, mostly fitting, but you know, you change around the orientation here and there, and yeah, there you go. Fits right within the drive bay. So what I'm gonna do is off camera, I'm gonna start doing CAD work, and I'm gonna manufacture a little tray to put all of these things on, and yeah, and that'll be a 5-inch wide type thing, and it'll go on the bottom slot, and it'll just be and yeah, we'll just connect it like it's a CD drive basically, and yeah, and that'll finish up that. And really, once we get that done, the only thing that'll be left is to install it, which will bring down the server for like 30 minutes. And yeah, and then once we're done with that, I can put it in some actual final spot, not here where it's expected to be serviced, where all the servicing happens. And yeah, and then later on, maybe at a later date, I don't know, maybe off camera, I'll finish writing the drivers for it, and yeah, hopefully that'll make it all work, and yeah, it'll look cool. But you know, but anyways, so let's get at least a jump cut to when we get started on the printing of that. Alright, so I have done some CAD work, and if I can just transition over to the CAD software. Well, what we've got is basically we've got the 5-inch drive bay thing. Apparently it turns out it's actually 5.75, or I guess 5 3/4. It's at least what these calipers have said. They're kind of the cheapy ones. But anyways, so we made that. You got your Arduino, it goes here, and here's where the actual board goes. It's kind of a replica of how it looks, of how the board looks in this format, but actually in design, or in how it's supposed to be. And then there's the little screw holes, which they look a bit funny, but they're all M3, or at least use an M3 thread, and they're designed for these metal threaded insert things. It's easier for me to just use that, because all of the computer screw set that I've been using for, actually I think this video and even part 1, they're predominantly, most of them, they're predominantly M3, except for like the ones for because standard PC sizes. So I've got M3 inserts in abundance here, so yeah, I'm going that route, and it's easier for me to do that. Anyways, so I'm gonna get this all exported and sliced, and next thing you'll see is probably gonna be a little snippet of a time lapse of my printer at least printing out the bottom portion of this. So let's get right into that. Alright, so print came out. Turned out pretty nice actually. Did a nice little fit test in this spare drive bay that we picked up for this thing. And it just slides into one of the 5-inch drive bays that are everywhere on this system. And the screws fit pretty nice. So now the next step is to install the metal threaded inserts with a soldering iron, and we'll just get the standard CD-ROM drive type screws in here, and in fact that'll be all of the screws that we need for this, and let's get that installed. Alright, so our little tray has been assembled. Unfortunately though, I had to miss a couple screws because I didn't get the angles right on the inserts, but there we go. And this will fit in the drive bay. Then we got this USB kind of sticking out like a SATA port. Unfortunately though, I did have to kind of, in the CAD I did have to make a bit of an odd concession, because you've got all these, the pins are now vertically kind of mounted, but it should be able to work, because hopefully we'll have enough clearance to do that. So let's get it installed. Let's get the server down for one last time, and we'll get that installed. Alright, so we've installed it. Actually went in pretty flawlessly. So I know now one thing that'll probably be I'm pretty sure I'm going to get roasted in the comments for is the proximity to the drive. Luckily it doesn't go the full depth, and also the drive, as it turns out, is a helium seal of some sort, because it's kind of how they can get these big sizes in. So it really cannot have airflow, because if it did, we'd have some problems. It can still overheat though, which is a thing, so we still have to have some consideration, but it's a design from, that's a problem from when the case was designed. So another big problem is getting it all wire managed, because they can't really do wire management, and unfortunately though, kind of ruined the whole wire management on this. So what I'm going to do is I'm going to cut to when I get the wires properly managed, and this back in. Alright, so we've gotten everything all installed and running, and unfortunately though I kind of failed to do a bit of other parts of cable management. I meant to run everything underneath this support plane for graphics cards and PCI stuff, but oh well, that's neither here nor there. Everything works. I'm not gonna, if it ain't broke, I'm not gonna really fix it. I mean, you know, like I can press and hold the reset button and we can reset and everything works just fine otherwise. Yeah, again, if I had to change any of this, I'd probably upgrade the front panel to using USB 3 and then just, you know, not use a USB 3 header, but, you know, kind of desperate times call for desperate measures, I guess. But, yeah, so now that everything's installed, I'm going to unplug it and I'm going to move it over to everything, because I did have it plugged in just to test it. And of course, I got to get these screwed in, and we will be pretty much done. In. Alright, so it's in its final spot. Let's power it up, and if I can get to the power switch, and there we go, we've got that. Now let's try turning it on, and now, if it's on my keyboard, should be in the correct place to be doing stuff. It would help if I have the monitor turned on. And if the monitor, there's the setup it's going to be on for basically for all the time that I'm going to have this thing, you know, for forever basically. Yeah, or at least the foreseeable future. And yeah, looks nice. I will say my lighting is a bit brighter than what they used. Now granted, I am running it at full 3.3 volts, but yeah, that's working pretty good. Not a huge fan of why it's taking a while to get to Linux, but yeah. Oh, there we go. Yeah, because yeah, we're in a different spot now. Hopefully the auto mount works, which will make it be usable for a lot of things. But yeah. All right, and now we just have auto login, and yeah, okay. Nice and quiet right now. Yeah, so let me get some stuff done, and yeah. Alright, so now that the server is back online, let's talk about the next steps we should probably take on this thing. So now that we've gotten the Lite system working, I should now write the drivers for that Lite system, because otherwise the power supply fail light will be constantly flashing, and we don't really want that. So we'll have that running. Yeah, and hopefully once I get it done, or probably pinned to the description of this video, will be the actual link to the drivers, because I'll be probably posting them on GitHub, you know, have them as a nice open source for anybody else who comes on one of these incredibly rare machines and is like, oh man, I'd like the status LEDs to work once more. Well, now you can build a thing that can do the status LEDs. Anyways, with that being said, that's it for today's video. If you like what you saw, there's a like button and a subscribe button. There's definitely going to be more computer-related shenanigans in the future, because, if it would stop falling out of my hand, I have just recently acquired one of these new, another AMD graphics card, because the NVIDIA GPU in my gaming PC does not like Linux at all. So, join me in a couple weeks from now, and we will have, we will have that installed, and yeah. And thanks for watching, and bye.